According to the 2020 National Electrical Code, it is permissible for a 100 amp main panel to feed a 100 amp subpanel, even if there are other loads present on the main panel. Several conditions must be met to ensure code compliance and safety. Firstly, the main breaker in the main panel must be rated at a minimum of 100 amps. This is essential to provide adequate overcurrent protection for the entire system. Secondly, the subpanel itself must have a rating of 100 amps or less. This rating indicates the maximum current the subpanel is designed to handle safely. Thirdly, and most importantly, the total load in the main panel must not exceed the rating of the main breaker. This requires a careful calculation of all the loads connected to the main panel, including the subpanel and all other branch circuits. To determine if the installation complies with the NEC, a load calculation must be performed. This calculation involves adding up all the connected loads and applying any applicable demand factors. Demand factors are multipliers that reduce the calculated load based on the likelihood that all connected loads will be operating simultaneously at the maximum rating. The NEC provides tables and guidelines for applying appropriate demand factors to various types of loads such as lighting, appliances, and heating equipment. Here is a more detailed breakdown of the steps involved in performing a load calculation. 1. Determine the general lighting load. For dwelling units, the general lighting load is typically calculated at 3 volt amps per square foot. Multiply the square footage of the dwelling by 3 volt amps to obtain the total general lighting load. 2. Calculate the small appliance and laundry circuit loads. The NEC requires a minimum of 220 amp small appliance branch circuits for the kitchen and dining areas, and 120 amp laundry circuit. Each of these circuits is calculated at 1500 volt amps. 3. Determine the individual appliance loads. List all appliances that will be connected to the panel, such as refrigerators, dishwashers, washing machines, dryers, ranges, and air conditioners. Obtain the nameplate ratings of these appliances, which indicate the volt ampere or wattage requirements. 4. Calculate the heating and cooling loads. Determine the total heating and cooling loads based on the type of heating and cooling equipment installed. For central air conditioning systems, use the nameplate rating of the air conditioner compressor. For electric heating systems, use the total wattage of the heating elements. 5. Apply demand factors. Once all the individual loads have been calculated, apply the appropriate demand factors as specified in the NEC. For example, a demand factor of 100% is typically applied to the first 10 kilowatts of the general lighting load, and a demand factor of 35% may be applied to the portion of the load exceeding 10 kilowatts. Similar demand factors are applied to other types of loads. 6. Calculate the total connected load. Add up all the individual loads after applying the demand factors to obtain the total connected load. 7. Compare the total connected load to the main breaker rating. Ensure that the total connected load does not exceed the rating of the main breaker. If the total connected load exceeds the main breaker rating, steps must be taken to reduce the load, such as installing a larger main breaker or reducing the number of connected loads. In the specific scenario described, where a 100 amp main panel feeds a 100 amp subpanel, it is crucial to carefully consider the load on the subpanel. The subpanel is intended to serve specific loads, and its total load must be included in the overall load calculation for the main panel. If the subpanel is fully loaded to its 100 amp capacity, it could potentially overload the main panel if other significant loads are also connected to the main panel. Several factors can influence the load calculation and determine whether the installation is compliant. One such factor is the diversity of the loads. Diversity refers to the fact that not all loads will be operating simultaneously at their maximum rating. For example, lighting loads may be reduced during daylight hours, and appliance loads may only operate intermittently. The NEC allows for the application of demand factors to account for load diversity. Another factor is the type of loads connected to the panel. Different types of loads have different demand characteristics. For example, continuous loads, such as lighting loads that operate for extended periods, are required to be calculated at 125% of their rating. Non-continuous loads, such as appliance loads that operate intermittently, can be calculated at 100% of their rating. The size of the conductors feeding the main panel and the subpanel must also be considered. The conductors must be sized appropriately to carry the calculated load. The NEC provides tables that specify the ampacity of different conductor sizes based on their material, insulation type, and installation method. The overcurrent protection devices, such as circuit breakers or fuses, must also be sized appropriately to protect the conductors from overcurrent. The overcurrent protection devices must have a rating that is equal to or less than the ampacity of the conductors they protect. It's important to note that the NEC is a minimum safety standard, and it is always advisable to exceed the minimum requirements where possible to provide additional safety and reliability. For example, installing a larger main breaker or using larger conductors than required can provide additional capacity and reduce the risk of overloading the system. In addition to the NEC requirements, local codes and regulations may also apply. It is important to consult with the local electrical inspector to ensure that the installation complies with all applicable codes and regulations. Furthermore, it is recommended to consult with a qualified electrical contractor to perform the load calculation and ensure that the installation is safe and code compliant. A qualified electrical contractor has the knowledge, skills, and experience to accurately assess the load requirements and select the appropriate equipment and wiring methods. They can also ensure that the installation is performed in a safe and workmanlike manner. In summary, a 100 amp main panel can feed a 100 amp subpanel if the main breaker is rated at least 100 amps, the subpanel is rated 100 amps or less, and the total load on the main panel does not exceed the rating of the main breaker. A load calculation must be performed to verify compliance with the NEC, and all applicable codes and regulations must be followed. Consulting with a qualified electrical contractor is recommended to ensure a safe and code-compliant installation. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself from electrical shock and other hazards. Always disconnect the power before working on electrical equipment, and use appropriate personal protective equipment such as insulated gloves and safety glasses. If you are not comfortable working with electricity, it is best to leave the work to a qualified electrical contractor. The NEC also addresses the use of overcurrent protection devices in both the main panel and the subpanel. The main panel must have a main breaker that provides overcurrent protection for the entire panel. The subpanel must also have a main breaker or a set of fuses that provides overcurrent protection for the subpanel. The overcurrent protection devices must be sized appropriately to protect the conductors and equipment they serve. The NEC specifies the maximum allowable overcurrent protection for different types of conductors and equipment. The location of the subpanel is also a consideration. The subpanel must be installed in a readily accessible location. The NEC defines readily accessible as capable of being reached quickly for operation, renewal, or inspection without requiring those to whom ready access is requisite to climb over or remove obstacles or to resort to portable ladders, and so forth. The subpanel must also be protected from physical damage. The NEC provides guidelines for protecting electrical equipment from physical damage. The wiring methods used to connect the main panel to the subpanel must also comply with the NEC. The wiring methods must be suitable for the environment in which they are installed. For example, wiring installed in wet locations must be rated for wet locations. The wiring must also be protected from physical damage. The NEC provides guidelines for protecting wiring from physical damage. The grounding and bonding of the electrical system are also critical for safety. The grounding system provides a path for fault current to flow back to the source, which helps to trap the overcurrent protection devices and prevent electrical shock. The bonding system connects all the metallic parts of the electrical system together, which helps to equalize the voltage and reduce the risk of electrical shock. The NEC provides detailed requirements for grounding and bonding electrical systems. These requirements must be followed carefully to ensure a safe and effective electrical system. In addition to the general requirements for subpanels, the NEC also has specific requirements for subpanels installed in dwelling units. These requirements address issues such as the location of the subpanel, the type of overcurrent protection required, and the grounding and bonding of the subpanel. The NEC also provides guidelines for sizing the service entrance conductors for dwelling units. The service entrance conductors are the conductors that run from the utility company's transformer to the main panel. The service entrance conductors must be sized large enough to carry the calculated load of the dwelling unit. The NEC provides tables that specify the minimum allowable size of service entrance conductors based on the size of the dwelling unit and the calculated load. The NEC also addresses the use of surge protective devices. Surge protective devices protect electrical equipment from voltage surges, which can damage or destroy sensitive electronic equipment. The NEC recommends the installation of surge protective devices in dwelling units. The surge protective devices should be installed at the main panel and at any subpanels that serve sensitive electronic equipment. The NEC also provides guidelines for the installation of arc fault circuit interrupters, or FSIs. FSIs are circuit breakers that are designed to detect arc faults, which are a common cause of electrical fires. The NEC requires FSIs to be installed in certain circuits in dwelling units, such as bedroom circuits. The NEC also addresses the use of ground fault circuit interrupters, or GFCIs. GFCIs are circuit breakers that are designed to detect ground faults, which can cause electrical shock. The NEC requires GFCIs to be installed in certain locations in dwelling units, such as bathrooms, kitchens, and outdoor areas. The NEC is a complex and comprehensive document, and it is essential to consult the NEC and any applicable local codes and regulations when performing electrical work. It is also recommended to consult with a qualified electrical contractor to ensure that the installation is safe and code compliant. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself from electrical shock and other hazards.